Hello, and welcome. My name is MiniBetrayal, and this is Factorio Megabase. Last episode, we got up and running a lot of plastic. Today, just having a quick look to see what I've actually got in here. Let's just go. We are going to work on red circuits and possibly blue circuits as well. That largely depends on just how long it'll take us to get set up there. So I've just picked up a bunch of stuff. So red circuits, we've got some copper there that we can smelt, turn directly into wires. Oh, that's a thing. Did I bring smelters with me? Where even are they? There. I did not. Okay, so we won't be able to do it all in one in any case. But yes, so we'll mine that up, we'll turn it into copper plates, we'll turn that into copper wire. We've got the plastic there, we have got green circuits by the dozen over here. Also, I've been slowly filling these up with the necessary speed modules to make sure that we actually do get 8 compressed belts. But otherwise, I think we're good to go. So yeah, I'll just wait for the train to get there, I guess. Alright, here we are. Just make sure that's not going to run away. I think we're okay. Right, so I guess the first thing to do is to set up some miners, see how much copper we can actually get out of this. Alright, so we've got a little bit of tidying up to do, but we should have plenty of copper. Right, so I've also got this, which is my sort of basic red circuit setup, where you put in green and plastic on this line and copper in on that line. And then everything just sort of works itself out. Maybe I should include a balancer on this. No, I think I might do just that. Like that. That way the red circuits are, in theory, always balanced. Of course, the other thing I need to do is figure out exactly how much of this I can use, because the majority of those green circuits will actually be going towards blue circuits, most likely. Now, I did do a little bit of calculation at the end of last episode. I don't remember what any of that was. So, if we look at a blue circuit majig, so that takes 20 green circuits to make a blue circuit, but a red circuit takes 2 green circuits. So a blue circuit actually takes 24 green circuits. We have 8 lanes of green circuits, which means we can get 3 lanes of blue circuits. No, it doesn't. 1 lane of blue circuits would therefore require 24 lanes of green circuits. We have 8 lanes of green circuits, which is a third of 24, so we can get a third of a lane of blue circuits, which is a yellow belt of blue circuits, which I seem to recall saying we could do, so that sounds right. Maybe what I should do is integrate a blue circuit machine into this somehow, like have blues and reds working together. Of course, the other thing I need to think about is that this is actually going towards making modules, which require red, blue, and green circuits. Okay, so let me do some quick calculations based on maximizing output of Mark III circuits. Sorry, Mark III modules. Okay, it has taken an embarrassingly long time, because I did a whole bunch of working out, something didn't look right, So I did a whole bunch of working out, got a different answer. So I did a whole bunch of working out and got the first answer again. But to make a single Mark III module, one of these guys. Oh yes, also we've finished some science. Let's just do some more, I guess. Whatever. Yes, to make a single Mark III module, it takes 30... Well, it takes 5 red, 5 blue, and 5 Mark II. If you split that Mark II into its components, it takes 30 red, 30 blue, and 4 Mark Is. If you split those Mark Is, it takes 30 blue, 130 red, and 130 green. Sorry, not 4 Mark Is, it takes 20 of those Mark Is. And then the next stage is where it gets interesting. So we've got 30 blues, 130 red circuits, and 100 green circuits, all to make one Mark III module. That doesn't sound so bad. Now let's split the blue circuits into reds and greens. Now, to make a single Mark III module, it requires, well, 150 sulfuric acid, but also 190 red circuits and 700 green circuits. If you then split that red circuit up, we now require a total of the 150 sulfuric acid, 390 plastic, 760 copper wire, and 1080 green circuits to make a single Mark III module. So, turns out if you do, let me just double check this actually. Yes, if you do that 10,000, sorry, not 10,000, that'd be a bit much. If you do that 1080 and divide it by 45, the speed of a blue belt, that would be 24 compressed belts of green circuits would get you 1 module per second. Just sit down and think about that for a second. But we have 8 compressed belts. So if we divide all of those numbers by 3, so 360 green circuits, that's as much as we're making. That is also 126 2/3 plastic per second, which is 2.82 belts, somewhere around there, of plastic, which we've got, because we've got the 7 and a bit belts of plastic ready to go. For copper, we need 253 1/3 every second, so divide that by 45, and that's 5.6 belts, compressed belts, which we should be able to get out of this. On top of that, we also need 50 sulfuric acid per second, which shouldn't be too tricky. I guess we will see. But that gives us some numbers that we can work to. So, I suppose the question is, where do we want to do this? And how as well. I still haven't considered. So in our final row, how fast are the Mark III modules made? They're made in 60 seconds. So because we divided all of that by 3, we should be able to have 20 of these actually running full time. Which isn't bad. Okay, while I think a bit, I'm going to do some tidy up here. Be right back. Alright, so I do not have the electric furnaces with me that I require, but I'm going to put them in this area. And, well actually maybe I should put them down here. How much space do I have between this and the rails? Enough, I think. Let's get some of this rock nonsense out of the way. So essentially I'm going to smelt it all into copper plates, and then I'm going to put in basically these. So how many of these do I need? So I need 63 1/3 per second, and this setup can make 1 per second. So maybe I should find a bit more space. Okay, so hang on, let me just pop that down. So each of these will eat then 2 plastic per second, and we can have 22 of them on a row then. That eats 2 copper per second from a full belt of copper. That eats 2 plastic from half a belt of plastic every second for each of them. Yeah, I think something smells off, like having 22 of these in a row like this. I know I've got blue belts. Let's just have a quick comparison to back at base. Maybe it would work. Alright, how many is that? That's 4. I do think though that having 22 of them in a row is probably just a bit much for space's sake. So I need 63 1/3, so 64 of them. That's quite a nice number actually. So if I do 64 divided by 4, that's 32, 16. So 16 rows like this, although I do actually need some of that as well. Okay, so that's 2 rows. That then is 4. That then is 8. And this would be 16. Of course, it is all in exactly the wrong place. But I think that seems reasonable. So yeah, I think I'll pop that down about there-ish. I'll let my bots build it and just go and grab whatever I'm missing from back at base, I guess. Alright, so I've just got back with a whole bunch of stuff, so I should be able to finish at least the majority of this setup. I'll show you what I've got so far. It's basically what you've already seen. I've just penciled in a bit of belt work. So I've got 2 inputs. This one here will be the input for copper plates. This one down here will be the input for plastic. We have another input over here. This is where the green circuits are going to come in. This splits the green circuits between the red circuit build and the blue circuits, which will go off a little bit further south. And the red circuits themselves, they come out on the bottom down there. Okay, so I think we are about ready to go here. I have put everything where it needs to go. I've even put some lights down. I've hooked up the interconnecting belts between the plastic and the copper, save for little bits here and there. The only thing that remains to be on its way is actually the green circuits, which is really quite far away. So I'm going to get a train, or more likely 2 trains, going back and forwards. for which I need a better rail system. At the moment, this singular rail is not quite enough. So I started setting up a train system to get the green circuits back and forth, and then realized how much work that actually is. So just for now, just to test it, I've set up some temporary stations. You can see I've got like landfill and ghosts ready to go in, but this is actually quite a long way to go. Right, so there's a couple more things I need to do to get this set up. Firstly, I want to just sort of section off that waiting area there, and then this here, a few more things that need to go in. This is nearly a loading station. I say nearly because I've just realized that all of the inserters are facing the wrong way. Additionally, I still don't actually have enough inserters. I'm missing 30 of them. God damn it, I really hope I don't have to go back. Well, that brings us up to 30 at least. Okay, so yeah, tiny bit more to do just in terms of getting this station set up, and I have a similar one at the red circuit end, which is already done. On my way here, I remembered that there was one more slight change I need to make to the red circuit build, because at the moment all of the red circuits are just being put on one side of the belt, which is obviously not okay. But then, yeah, once that's done, we can at least test this and make sure that it's working. Alright, so I think I am just about ready now for this test. So, let's plug some things in. So, first up, we have the plastic. Go. Then we have the mining. Go. So the mining goes into the smelting area, which then heads into our red circuit production. While that is going, so we'll set this train to automatic. It's just going to run backwards and forwards, and at the moment as well, this is very much a temporary train because it hasn't been given a way of automatically refueling. I've given each train there a nuclear fuel, but once that runs out, that's it. Okay, so that first little bit of copper is starting to make its way in. Yeah. This won't be compressed. That's fine. Remember, we only need, I think it's like 5.5 belts worth. And I'm seeing like probably 7 belts worth. Right, the plastic's coming in. Interesting that there's none on that top belt. Oh, there's a belt missing. That's why. I'll go and see to that shortly. Luckily, there's an 8/8 balancer here, so, and in fact, I think there's an 8/8 balancer on the other side of it, and we're only making slightly more than 7 belts anyway, so should be all right. Now, all the plastic should be fed down just one side there. That is all looking good. All right. Now, I do still have a couple more of these to make, but I ran out of circuits, of all things. Luckily, this is where all of the circuits are, so that shouldn't be too tricky. Alright, so I just need to wait for those to get built, and then I'll plug the circuits back in. Okay, meanwhile, things are almost backed up here. Yeah, I'm not seeing any movement there. Not seeing any movement there. Okay, so yes, it is literally just the green circuits we're waiting on. Alright, I think that's everything. So, let's turn that on. We'll hop in. We'll follow the train back. No, let's hop in the middle so I can actually see the whole train at once. So each belt has 8 stack inserters to deal with it, which should be absolutely plenty. I believe that I'm losing compression a little bit there. Ah, these ones aren't fully speed beaconed. That would be why. The ones that are speed beaconed are interestingly still having problems. Why is this so much more on one side than the other? Oh, right. No, that makes sense. I must admit, I don't actually remember. Was this not 8 compressed belts? Was it just 8 very fast belts? Or very full but not compressed? Maybe I should look into that as well. I'm not totally fussed. I mean, it is so many green circuits. And I forget how many can actually go in. So it looks like we're coming up on half full. And we've got 30,000. Okay, about 3/4 full now. And we're at 49,000. So I suspect what this would be... Well, actually, I can work it out. Because each wagon has 40 slots. Each stack is 200. So each wagon is 200 times 40 is 8,000. 8,000 circuits. And we have 8 wagons. So 8,008, that'd be 64,000. 64,000 circuits per train load. Alright, we're just about done. And there we go. Alright. So, we'll see how long this actually lasts. But yeah, given that it's actually still quite a long way off. It needs to last at least as long as it takes, like, the other train to get there and back and refill. So I don't have another train yet, but I will do. Okay, so pulling into the station now. Yeah, so like I said, with 8 stack inserters per wagon, it can definitely use up a compressed blue belt. Similarly, 8 ones emptying the wagon can fully compress a blue belt. Yeah, so more than is necessary. That's facing the wrong way. More green circuits than are necessary are coming down this way. In fact, I suspect that many of these are facing the wrong way as well, because I'm seeing a lot of nothings. Okay, well that's why we test things. That's facing the right way. That's not. Okay, well that should fill up the other side of... Oh, missing a belt there. that all looks good to me, apart from this bit down here. Yeah, so as I mentioned earlier, everything is just being put on one side of this belt. What I think I might do... Let's move that for a sec. Yeah, what I want to do is move all of this down by one. And that should give me enough space to... Oh. Fine, just get rid of a bunch of crap. Should give me enough space to have a side balancer like that. Okay, I think that's everything. I'm making a decent amount of red circuits. Let's just... oh, excuse me. I've got this belt down here to fix. That was easy. What I'll do, just as a... I guess a kind of way to test how this holds up. Yes, what we can do just to test it is feed red circuits just onto a belt like that as quickly as they can, and we'll see what happens up here. In fact, another thing I can do, if I just ditch a bunch of stuff quickly, is I can pick up the red circuits myself. So we can't possibly be making 2 compressed blue belts of red circuits, right? We're only supposed to be making 63 1/3, which is... Well, 1 compressed belt is 45. Which would leave us 20-ish. I suppose we should be getting 1.5 compressed belts, give or take. But yeah, I'm not seeing any gaps at all at the moment. Maybe it's just going to take longer than I thought. Power is noticeably higher. Coming from the furnaces, interestingly. And the assembly machines as well, I guess. Yeah, these last, what's that, 6 columns? They're still backed up. Okay, it does actually help if I take properly from all 4 lanes. I don't think I was only taking from 3 of them. Yeah, that's dropping down quite quickly now. Interesting, that last one has gone, but those 3 haven't. You can still see there's red backed up over there. Okay, it's starting to drop down, but it's doing so slowly. I can keep simulating this drain on it, but I think we are good for red circuits. One more quick look at power. So, what's that? About 1.4 gigawatts at peak. Yeah, I don't think it went any higher than that. Okay, so next thing to do is the blue circuits, which will require proper train stuff. Oh, it's actually been back and left again. I didn't see any gap in the green circuits, but mind you, I wasn't looking for it, so I guess I'll keep an eye on that. Yes, next thing is blue circuits, which just require red circuits and tons and tons and tons of green circuits. But also sulfuric acid. So I'm thinking we set up a little bit over here. There's some crude oil I can turn into petrol for sulfur. and there's iron dotted around. I haven't seen one both close to here, and there's iron and oil close to each other. It could go up there. Maybe there's some iron round about there or something. Don't know. But in any case, that is not going to be happening this episode. Yes, that little section of the build took far longer than anticipated. I said, if it doesn't take long, we might do the blue circuits, thinking it'll probably be either alright or just a fraction too long, but no, I have already been playing for over 4 hours just to get this bit here done. So I think that will be a next episode job. Next episode, I will... Okay, so, well, I'm not sure what will be done next episode and what might be done the episode after, but on the to-do list is improving the train line so we can have multiple trains running between whatever station ends up finally being here rather than Elangeswaran. Thank you for supporting Factorio. And James Chadders. And the same to you. Yeah, well, so we can have multiple trains running on that line. So that is on the to-do list. Also on the to-do list is local production, or at least reasonably local production, of sulfuric acid. That can also be shipped here by train. In fact, the iron is reasonably close, and there's water everywhere. So what we might even do is ship either petrol or just sulfur here and make the sulfuric acid on site. But then, next to do is the blue circuits. Now, according to my notes, where are they? We need actually just 30 blue circuits per second. Which isn't much compared to what we've been doing today, but blue circuits are usually made in 10 seconds, is it? I don't know, I don't have any of them on me. Also, one thing that has literally just occurred to me is that, of course, these don't have a crafting speed of 1, do they? They have a crafting speed of 1.25. Which may explain why the red circuits was building up as it was. No, it does matter. So we've got too much red circuit production here as well. Well, I mean, I guess it's better to have too much than too little. But that is something else that we'll be looking into. So because the blue circuits are made in... Just going to borrow you for a second. They're made in 10 seconds. So you'd need 10 machines to get 1 per second, so we need 300 to get 30 per second? No, I'm reading my wrong notes. That's before we divide everything by 3. We actually just want 10 blue circuits per second. So we want 100 machines making them. Then we use those blue circuits plus the remaining red and green circuits to make the modules. Mark 1, Mark 2, Mark 3. So we'll be making... well, 1 Mark 3 module is 5 Mark 2s and 20 Mark 1s. So if you just divide all of that by 3, that's how much we'll be making per second. And we'll end up with 1 Mark 3 module every 3 seconds. And probably what I'll do, I haven't decided yet, is I will split them all evenly. So effectively we'll be making 1 module Mark 3 every 6 seconds for each speed and productivity. But if you have any comments, do let me know. If you happen to be in the Discord, give me a shout, let me know what you think. Otherwise, feel free to just leave a comment below. In the meantime, though, I will say thank you very much for watching, and I will see you again soon.